Okay, so we are on to topic 4, which is 3.4 file organization. So in this topic, we're going to be looking at how to describe sequential, index sequential, and random file access, explain the use of multi-level indexes, explain the techniques to manage overflow and the need for file reorganization, explain the purpose and be able to use a hashing algorithm, describe the need for file security, backup, generations of files and transaction logs, understand the need for archiving, and describe the need for file privacy, passwords for access, and the purpose of encryption. So just a recap from AS on serial files and sequential files. So what are serial files? These are records stored one after the other in no particular order. Records are just added onto the end of the file. The main use is a transaction file, for example, recording sales in a shop or employees clocking in. It can be used with either tape or disk storage. And the advantages are adding records is very straightforward and fast, but disadvantages very slow to search. I'd like you to think as to why that might be. Okay, sequential files. So what are sequential files? Records are stored one after the other in order of a key field, for example, a stock code or an employee ID. Records are added into the correct place in the file. And how might they be added into the correct place in the file? Often used as a master file, for example, a stock file, to allow records to be searched via a key field. It can be used either with tape or disk storage. The advantages are if updating a number of records in a batch update, it can be done quicker to perform the update if the master file and also the file being updated from are in sequential order. When searching for a non-existent record, it'll be quicker to spot that it just doesn't exist. A very quick binary search can sometimes be used if we're using a direct access method. So some disadvantages are it can be slow to add records to a sequential file because they need to be added into the correct place. So a disk is split into thousands of concentric circles called tracks and a number of sectors which divides them up into a nice little pie. Okay? A block is where a track and a sector intersect. A computer reads and writes a block of data at a time, and this is the smallest unit of transfer. So each disk block could hold several records. For example, part of a sequential file of students. So block 10 contains information on Jones, Ali, Chi, Perry, and another Jones. If a new record, 7025, was to be added, the computer would read in the whole block of 10 into memory and add the record to the copy in memory, which will be very quick, and then write the whole block back. So it would just be a case of reading that whole block in, adding it in, and writing it all back again. And then it'd write it into there, into block 10. So an indexed sequential file is a sequential file and thus has all the advantages associated with it of a sequential file, being quick to update, modifying large numbers of records in a key field order. But index sequential files are slightly different and also have an index file or many index files, which allows records to be searched for directly very quickly without having to read through all the other records in the file first. An index sequential file is therefore considered the jack of all trades, so to speak, having the properties of a sequential file, but also being very quick to direct access via the index to go straight to the required record. But it's not quite as quick as random direct access files, which we'll come on to later in the topic. Index sequential files will not work on tape storage, as there is no way to go directly to a record on a tape without reading through all of the previous records first. So an index sequential file with a single index. If we were to add a new record with the key field 876, the index file is loaded into memory. And so the number of key ranges. So we will be looking at key field 876, which would send us to block number 11. okay? Because that is where our key field 876 will be stored. Block 11 is loaded into memory and the new record is added and the block written back into the drive again. Sometimes there may not be enough space in the block to fit the new record, and this is known as overflow. If there's not enough space in the block where the record should be written, then there is an overflow. A number of blocks are set aside in an indexed sequential file known as the overflow area. When an overflow occurs, the record is written into the overflow area, and a tag or pointer is left in the block where it is meant to be stored to indicate in which block the overflow area can be found. So there's some problems associated with overflow. As more and more records are placed in the overflow area, the time taken to search for the records becomes longer. And why do you think that might be? The index is searched and this indicates the block where the record should be. The block is located, which requires the disk read write heads to move, and the block is loaded in. The record is then searched for in this block. However, if there is a tag or point, it now needs to find the block in the overflow area. It adds an extra step and an extra delay. So we've got indexed sequential file reorganization. As more and more records are placed in the overflow area, it becomes slower to find the records. As records are deleted from files, there may be now room for some of the overflow records to move back into their home blocks. Therefore, periodically, for example weekly or nightly, a file reorganization program can be run. So this reads in each record sequentially through the file, writing it back into its correct home location. If after file reorganization there's still too many files in the overflow area, the indexes can be reorganized to allocate fewer records to each block. In larger files, having just one large index can make searching quite slow. In these circumstances, multi-level indexes can be used. So in a multi-level index, there's one main index. The index are referred to in more indexes, so it's like having an index in a book within an index. So the example here we're going to have a look at is a 3-level index. So we've got our main index here, so that's range of keys, 0 to 1000, and so on. So if we were looking for key field 2476, the main index is searched, and we know we need to go to index number 3. So we now load index number 3, and that is then searched. So 2476 is in index number 33. So index 33 is now loaded and searched. Our key field 2476 is in block number, or would be found in block number 124, and it's now ready to be read in the usual way. So if a file is going to be mainly searched using a key field, then random access file storage provides the fastest access method. It won't work with files on tape because it requires the ability to go directly to a record in the file. Examples could be a stock file for a shop such as Argos, where searches are made using the index number or the item number, or a bank where searches are usually made using the account number. So an algorithm, or a formula called a hashing algorithm, can be used to generate a disk address from the key field of the record being searched for. So we go key field hash disk address. There are hundreds of different hashing algorithms that can be applied, but the most used one is known as the division remainder method. This relies on the programmer making a decision on the maximum number of records that will be stored in the file. So the algorithm is disk address, key field, divided by the maximum number of records, plus 1. Remember that the mod function is the mod function that carries out a division and then returns the remainder as the answer. For example, 19 mod 5 would be 4, because 19 divided by 5 is 3, remainder 4. So as an example, let's consider a file in which we could have a maximum of 100 records. We want to add a record with the key field 849347 into the hashing algorithm. So we have our disk address 849374 divided by mod 100 plus 1. So that would give us the disk address 74 plus 1, which equals 75. Therefore, the record will be stored at position 75 in the file. In which address would the record with the key field 214499 be stored? It would be in address 100. And what about 873300 be address 1? 127374 75. But this is a problem because there's already a record in position 75, and this is known as a collision. So the record is placed in an overflow area and a tag pointer is left in the position 75, indicating that there is another record in the overflow area. The overflow area is then searched in a linear or serial manner. Note, this is just an example of a hashing algorithm. Do not use it in an exam question, just state what a hashing algorithm is, i.e. it generates a disk address from a key field. Keywords here, it generates a disk address from a key field. So problems as the file fills up, so we've got reorganization. As a random file gets filled up, more and more records will be in the overflow area. Or some of the records that were originally involved in the collision may have since been deleted. There could be space left to juggle the data around. Periodically, again, a file reorganization program can be run to rehash the records. If there's still an unacceptable number of records in the overflow area, an different hashing algorithm could be used. Okay, we've got file security and privacy. So I'm going to make another quick short video on that because I'm just going to run out of time. So come back in a second and we'll be ready to continue.